All right, so here is the last two questions from the free response section. So we're still working with that same problem. We still have the same velocity function, so I haven't changed anything. And now we're on part C. It says, find all times t in the interval at which the particle changes direction and justify your answer. Again, we've done this question before, so I won't offer as much explanation. If you need more explanation, go back to the previous video to figure out why we're doing what we're doing. So in the previous video, we explained that when a particle is changing direction, two things are happening. Number one, the velocity should be equal to 0 because that means the particle is stopped. And number two, the velocity function should be changing sign from positive to negative or from negative to positive because that means it's changing from going to the right to the left or vice versa, from left to right. So let's look at a graph of this function in between 0 and 5. We're going to figure out where velocity is equal to 0 and we're going to figure out which direction it's changing from. So I already have this equation typed up right here. I'm going to look at my viewing window again from 0 to 5. So the velocity only equals 0 two times in this interval. Again, on Desmos, it's super easy for me to figure out where these points are. On your graphing calculator, it takes a little bit more time. So on your graphing calculator, again, you have to either find the 0 by going to, from the graph, going to second calc, option 2 for 0, finding a value to the left, finding a value to the right, and taking a guess. And you have to do that two times. One for this first point at 0.536, and then you have to do it again over here for this second point at 3.318. I'm going to write those down really quick so I don't forget them. T equals 0.536, and t equals 3.318. Again, the second way of finding those values is if you graphed a second line at 0 and then told your calculator to figure out the intersection of that constant function at 0 with the graph that you've already drawn, whatever way you like best. Now, here at 0.536, notice that the values are going from below the curve, or sorry, below the x-axis to above the x-axis. That's from negative values to positive values, which means it's going from left to right. And then for 3.318, it's going from above the x-axis, those are positive values, to below the x-axis, those are negative values, which means it's going from the right to the left. So, to explain, we're going to say, in a complete sentence, the particle changes direction, at t equals 0.536 and 3.318 because v of t equals 0, and then I'm just going to say the particle is stopped. I'm going to use my little shortcuts. Do you guys know that this symbol means therefore? Therefore, the particle is stopped. And by the way, they don't mind on the AP test if you use little symbols like that as long as they are known symbols. So this is actually a mathematical symbol that means therefore, and anybody reading your paper will know that. And if they don't, then they can ask the person next to them because this is a mathematical symbol for that. And you can use little abbreviations like that for and or the at symbol for at. You don't need to necessarily write out full English sentences in that respect. So, because v of t equals 0, therefore the particle is stopped, and the velocity function changes from, the first one changes from negative to positive. That's from left to right. And positive to negative from right to left, respectively. Again, the reader will know if you list this t-value first and this t-value second, and then you say it changes from negative to positive first and positive to negative second, and then put that word respectively right behind it, that the first t-value and this first justification go together, and then the second t-value and the second justification go together. So that's kind of a short way of notating your justifications rather than having to list out all the t-values again and kind of offer an individual explanation for each part of it. So this is kind of a shortcut to that. Again, like I said in the last video, I know that this will give me a full credit response. I'm not 100% sure that every single one of these things needs to be in there. Like, for example, what I wrote in parentheses is me interpreting what I was looking for. I don't know if you need to interpret it necessarily, but I always say if you have the time, be as thorough as you possibly can in explaining what you're talking about, especially in this free response section when the reader is trying to get a grasp on whether or not you know what you're talking about. It's incredibly important that you're able to communicate to them that you do, in fact, know what you're talking about. So, if you're rushed for time, obviously, maybe the things in parentheses are not going to be your first priority because you're just trying to finish your sentence and justify it and get credit. But if you are not rushed for time and you have some time, make sure to be thorough. All right, last question. Same problem, same everything, just a different part of the problem. It says, is the speed of the particle increasing or decreasing at time t equals 4? Give a reason for your answer. Again, we've done this one already, so let's kind of cut to the chase and talk about what we need. To find out if speed is increasing or decreasing, we need to know the velocity at 4, and we need to know the acceleration at 4, and then we need to compare their signs. So, I'm going to do it on Desmos. You guys are going to do it on your calculators. So again, from the home screen, just as a reminder, you can evaluate the velocity from the home screen by recalling the y1 function and figuring out what y1 of 4 is equal to. And to recall this y1 function, just as a reminder, you go to alpha f4 to recall y1. So that will tell you the velocity at 4. I am going to go to Desmos to figure out the velocity at 4. Alright, so I'm going to say f of 4, the velocity, money sign, f of 4 equals, and I'm going to write that down so I don't forget, t equals negative 11.476. And then on yours, you're going to go to the home screen and you're going to go to math, option 6, I believe, for n derivative. No, option 8. Option 6, option 8, I don't remember, whichever one n derivative is. And you're going to recall the y1 function, you're going to put the important variable as x, and then you're going to put that we're evaluating it at 4. On Desmos, I'm just going to put f prime of 4. So f prime of 4, a of 4, is equal to negative 22.296. 296, yeah, that looks good. Alright, here we go. Last problem, let's justify, make sure we did it correctly. So we're going to write our work. Our work is v of 4 equals negative 11.476. And our second thing for work is a of 4 equals negative 22.296. And our answer with reasoning is the speed of the particle is increasing at t equals 4 because velocity at 4 and acceleration at 4 are the same sign. Bada bing, bada boom. This is the easiest one to justify in my opinion. We showed our work to show that they're the same sign. Again, you're not only allowed to write negative or positive, you have to show the actual number. And then we stated what the answer was, that the speed is increasing, and we gave a reason. We know it's increasing because velocity and acceleration are the same sign. End of story. Elfine.